Let's begin. Let's begin by talking about the single most important thing whenever we talk about resultant force. Okay, so whenever we talk about resultant force, we know that we are talking about the formula of F equals to ma. Okay, and F is known as the resultant force. Okay, last year we called this the net force. Okay, but this year we are changing gear. We're calling it the actual name, which is the resultant force. Okay, now the single most important thing, and this is where I want you to answer me this. There are two situations where the resultant force is zero. Okay, when the acceleration is zero and the resultant force is zero, what are the two possible explanations for this? Let's have Wilson to answer this first. What is one possible situation where the acceleration and the resultant is zero?
Constant speed or in stationary.
Okay, very good. Okay, this is very important. It is moving with a constant speed or it is not moving at all. This is the singular most important thing that we need to wrap our heads around. Okay, in order for us to really master this, we must remember this. If it is constant speed and or it is stationary, then the acceleration is zero. Okay, acceleration zero does not necessarily mean bahawa dia tidak bergerak. Dia mungkin bergerak, but with a constant speed. Okay, the second thing that we need to remember about what we learned yesterday is that if there is a resultant force, what does this mean? Let's ask Wilson. Since I have Wilson, let's ask Wilson. Wilson, the tennis ball. If there is a resultant force, what does this mean? Sorry, is Wilson there? What does this mean? If there is a resultant force, means the object is going to move with what kind of movement?
Constant velocity.
Cannot. Constant velocity is this one. Constant velocity means no resultant force. The resultant force is zero. Now I have a resultant force. Sorry?
Acceleration.
Okay, very good. So there is going to be an acceleration. Okay, very important. If there is a resultant force, there is a acceleration. If there is no resultant force, there is no acceleration, but it may still be moving. Wow, I like Wilson's hair. Okay. Sorry. So today we're going to look at three different situations, okay? Out of which number 2 and number 3 are important, are the actual tough part, okay, of applications of resultant force. Okay, the number 1 application is, for example, like this. We have an object that moves horizontally or vertically. We covered a little bit about this last year, and I'm just going to ulang kaji with you now. So over here, you have a coconut. Oh, sorry, please forgive the spelling. Coconut, okay, not a coconut. You have a coconut of mass 2 kg that is falling with an acceleration of 9 meters per second squared. Okay, so dia bagi sedia the 9 meters per second squared, so don't care. So whenever you get a resultant force punya situation, let's start with the free body diagram. It's always a good idea to draw a free body diagram. So over here, we have a very nice green coconut, okay? And let's draw the free body diagram. What is the force? What are the forces that can possibly be acting on this coconut? Valerisa, give me the number 1 force.
Air resistance.
Okay, air resistance in what direction? Where is the air resistance? Going up or going down?
Up.
Okay. Okay, so the air resistance is going up. I'm going to call this R. Okay. One more force. One more force that is acting on this coconut. Jericho.
Gravitational force.
Frictional force and resistance, we will call it the same. Okay, but actually frictional force is more on horizontal. Okay, kalau atas bawah kan, if something is moving through the air, we call it air resistance. Okay, Try again. If there is a force upwards, there must be a force downwards. What is the force downwards called?
Gravitational force.
Okay, gravitational. Okay, gravitational force, otherwise known as the weight. Okay, thank you. So, number one, calculate the resultant force acting on the coconut. Since you are given the mass and the acceleration, then you should just directly count. Okay, which will give you, oh, sorry. Okay, so the weight and then the air friction, okay, or air resistance lah. The resultant force will be just darab terus, okay, F equals to MA, 2 times 9 equals to 18 newtons. Now, what this means is that in terms of the air resistance and the weight, it is also equal to 18 newtons, the resultant force. Okay, where is the direction of the resultant force? Adam, where do you think is the direction of the resultant force?
Downwards.
Okay, it's going to go downwards. Okay, the coconut accelerates downwards. That's why the resultant force is downward. And this is a very important thing. The direction of the acceleration will tell us where the direction of the resultant force is. Okay, very important thing, which I want you to hold on to this when we go into the second and the third situation. The direction of the acceleration tells us where the direction of the resultant force is. Okay, it also tells us who is stronger. Is the weight stronger or is the air friction stronger? Logically, the weight is stronger lah. That's why it's accelerating downwards. Okay, this is not very logical. Siapa yang tarik lebih kuat kan, di situlah dia akan pergi. Okay, so weight is stronger than the air resistance. That's why it's going to accelerate downwards. So what is the magnitude of the air resistance acting on the coconut? And this is where we use the resultant force. Okay, so in terms of the air friction and the weight, Brandon, can you tell me, in terms of the air friction and the weight, can you tell me the resultant force? The resultant force is equals to upper campur apa or upper tolak apa?
Weight plus air friction.
Okay, so it will be the weight plus the air friction. Except that, thanks, Brandon. Except that the friction, since it's in the opposite direction, I can say this as the weight minus the friction. Okay, so if you haven't realized until now, since yesterday I've been talking about this, there are actually two ways to count resultant force. One is you use MA. Okay, the unit is also in Newton. The second way is to talk about the forces that are involved. Dan dua-dua nilai ini mesti sama. Okay, so that's why you have W minus R. So R equals to W minus F over here. Saya pindahkan R lah. Okay, and since I have the F, which I calculated from B, I substitute as 18. Can I count the weight of the coconut? I can, by using the formula that we learned last year. Okay, 2 kilogram times 9.81. So I will get the resistance is 1.62 newtons. Okay, and that's how we apply the resultant force into the F equals to MA formula. Okay, remember, ada dua cara, okay, two ways to count resultant force. Okay, cara pertama guna MA. Cara kedua guna F1 minus F2 or F1 plus F2 lah, depending on how you want to do it. Okay, but the result will still be the same. Okay, so jangan fikir that this formula kan dia satu hala saja. No, it can be taken apart. Okay, and then nanti kau kasih sama dia balik. Okay, let's consider this situation now. Okay, that box of mass 50 kilograms is pushed by a force of 200 newtons. So here dia kena tolak 200 newtons. The frictional force against the motion is 50 newtons. Okay, so if you cannot see here, the frictional force is to this direction lah. Okay, frictional force mesti sentiasa menentang pergerakan. That's why it's called friction. Okay, what is the acceleration of the box? Okay, let's take it slow. What can we count here first? Which resultant force can we count? Can we count the resultant force cara kedua atau cara pertama?
Yang pakai force.
Okay, yang pakai force. Tell me what. Ya, betul lah itu. Tak payahlah A. Betul sudah. Okay. So tell me how to count the what's that? The resultant force kalau pakai force.
Yang 200 newtons tu minus dengan 50 newtons tu.
Okay, very good. So you get 150 newtons. Okay. Then we use the same resultant force to count the acceleration. Use the second method. So 150 newtons will be equal to M times A. Sebab the first method and the second method, the nilai is the same. Cuma kau guna method berlainan sahajalah. Okay, so I get 150 equals to 50 times A. What is my acceleration? It will be 3 meters per second squared. Okay, let's verify. Acceleration is positive. Okay, acceleration is positive means it's going to go to the right. Kalau kita tengok dari sudut resultant force, where is this box going to go? The box is going to go to the right because the resultant force is also positive. Okay, so just verify lah sometimes just to make sure that your calculation is correct. Okay, so ini adalah case yang senang, bergerak atas bawah dan bergerak kiri kanan. Okay, kalau bergerak atas bawah, we're talking about air resistance. Okay, sebab dia akan berlawan dengan udara. Kalau bergerak on a surface, di atas satu permukaan, okay, it will be the frictional force. Okay, daya geseran dalam bahasa Melayu lah. Okay, so that's situation number 1, kiri kanan atas bawah. Situation number 2, okay, situation number 2 is passenger in a lift. If you have your notes with you, it's a good idea to turn to page 6. Ada di sana itu page 6. Okay, so let's talk about the lift while you're taking out the page 6. Let's talk about the lift lah. Okay, so last time saya ada seorang murid lah. Okay, dulu I had a student. Dia sangat tidak suka masuk lift. Okay, she really hated going inside lift. And honestly, if you gave her the choice, dia lebih rela climb up 10 floors daripada naik lift. That's how much she didn't like to go on lifts lah. Okay, and the reason why she didn't like to go on lift is because dia tidak suka that feeling. I don't know whether you realize this, but whenever you enter a lift, when it starts to move, you get this very funny feeling. Macam kau tiba-tiba terasa tertarik ke bawah atau kau tiba-tiba terasa terapung ke atas. That kind of feeling lah. Okay, and that is actually explained by resultant force. Okay, so let's consider situation number 1. So you have a girl inside a lift. Okay, she is standing on a weighing machine. Okay, so she's standing on this weighing machine over here. Now the weight of the girl is acting downward. Okay, and since there is a force downwards, there must be a opposite force upwards, and we will call this opposite force the normal force. Okay, something new. This one tiada kaitan dengan air resistance. Adalah, tapi nanti kemudian. Okay, but let's say we're just talking about the girl sahaja. Since she is standing on a lift, on a platform, okay, there is a weight downwards, and there must be a opposite weight on the opposite direction. Okay, which we will call the normal force. Now, if the lift is stationary or if the lift moves upwards or downwards with uniform speed. Okay, tell me again, what does this mean? Stationary lift or upwards and downwards with uniform speed. Dari sudut acceleration, maksudnya apa? Irdina. In terms of acceleration, what does stationary? Sorry, go ahead.
Acceleration is 0.
Okay, very good. Acceleration is 0. Okay, and if acceleration is 0, still Irdina, if acceleration is 0, what is the resultant force?
It's also 0.
Is also 0. That means no matter what happens, the resultant force will be 0. Okay, take a look at the girl at the lift. Can you tell me what is the resultant force in terms of W and R? Remember the coconut situation just now? We also did the W and R. Can you tell me in terms of the W and R in this picture, what is the resultant force?
If W is equals to R.
Oh, okay. yeah. Okay, it's true lah. It's true. But actually, what I was looking for is W minus R is equals to 0. And because we've learned this since yesterday lah. Sorry. Okay, but correct. Kalau saya pindah R, W equals to R. Okay. So this W refers to the weight of the girl. Okay. Let me remind you again now. Weight, not the mass. Weight. Okay, in Newton. Sudah kena darab dengan 9.81. Okay. Now, R is very special. Take note of this and write this down in your notes if you have to. R is the reading on the weighing machine. Okay, that's why there's a weighing machine there. Okay, but the reading of the weighing machine will be the same as the weight of the girl in these two situations. If the lift is not moving, that's very obvious lah. If the lift is not moving, then you know the weight is the same as the weight of the girl is the same as the reading on the machine lah. Or if the lift is moving upwards and downwards with uniform speed, means kalau dia tidak accelerate, okay, the weight of the girl is the same as the reading on the machine. Okay, tapi itu syaratnya lah, either stationary or move upwards and downwards with uniform speed. That's situation number 1. Okay, sorry, I keep forgetting that. Saya tulis ni kan, terus macam ni. Okay, situation number 2. The lift moves upward with an acceleration of A meters per second. Okay, now we've said this before. If there is an acceleration, there is going to be a resultant force. Okay, memang ada resultant force. Okay, but now tell me this lah. Okay, tell me this lah. Kalau dia bergerak ke atas, okay, if it is moving upwards, the resultant force is in which direction? R or W? Let me skip some names. Michelle. I haven't heard Michelle this year, except for teacher Rosalind's class. Okay. If the direction of the acceleration is up, okay, where is the direction of the resultant force? Towards R or towards W?
W.
Towards W.
Yeah.
What do the rest of you think? Do you remember what I said earlier? I said, okay, this is very important now. Important thing. Okay. The direction of the resultant force must be the same as the direction of the acceleration. Okay, so it's okay, don't worry, we make the mistake here. Okay, just don't make the mistake in the future. The direction of the acceleration must be the same as the direction of the resultant force. Therefore, in this case, R is bigger than W. So kita punya resultant force will be R minus W. Okay, do you see that? R minus W will be equals to MA lah. Kalau saya pakai F equals to MA kan, the resultant force cara pertama mesti sama dengan the resultant force cara kedua. But the resultant force must follow the direction of the acceleration. Now, I'm going to change W to a formula that we learned. Oh no, what am I doing? Sorry. I'm going to change W to, sorry. I'm trying to erase this, but okay, never mind. I'm going to change W to a formula that we learned last year. Weight equals to mass times gravity. Okay, so R minus mg equals to ma. That means if I move the mg across, I'm going to get R equals to ma plus mg. Okay. And if you remember from what I said earlier, R represents the reading of weighing machine. Okay. And so we find that since there is a plus, the MA plus the MG, okay, the reading of the weighing machine, okay, R is going to be actually more than W. The reading of the weighing machine is going to be bigger than the weight of the girl itself. And this happens to us, whenever you go, okay, next time, bila kamu pergi Surya Sabaka Center Point atau whichever building that has a lift, okay, the first second, saat yang pertama, saat yang kedua, the lift has to accelerate. And when the lift accelerates, you actually feel heavier for a little while. Then lepas itu kamu akan kembali ke normal. Okay, if you've never thought about this, the next time you go into a lift, think about this. Bila kamu naik lift, bila kamu masuk lift dan kamu mau naik bahkan, you will feel a little bit heavier. Macam seolah-olah kamu kena tolak ke bawah. So what this girl is going to feel, she's going to feel as if dia kena tekan for a little while lah. Okay, then lepas itu dia akan stabilize balik. Sebab, sorry, wait. Okay, so she's going to feel a little bit heavier because the thing is accelerating upwards. Okay, next time you go into the lift, you think about this. Okay, so that's the second situation. Third situation. Okay, sorry. Third situation is, so the first one is they're stationary or not moving with acceleration. Second one is moving upward with acceleration. So the third one is moving downward with an acceleration. Okay, so same question just now. Okay, that I asked Michelle, I'm going to ask Oswald this time. Okay, Oswald, if the acceleration is downwards, okay, where is the direction of the resultant force?
W.
Okay, very good, towards W. Therefore, if I'm going to calculate the resultant force, it will be what?
W minus R.
Okay, W minus R will be equal to MA. Okay, and we established the fact just now that W sebenarnya adalah sama dengan mg. So mg minus R will be equal to MA. So how can I find out what is the reading of the girl on the weighing scale? Saya pindah lah. So R equals to mg minus MA. And since it is minus, what the girl is going to see on the weighing scale is dia akan kelihatan seperti lebih ringan. She's going to feel lighter. Okay, she's going to feel lighter because the lift is accelerating downwards. And that happens to us as well. Okay, same thing. The next time you go to wherever, go inside the lift and then go from the top floor to the down floor. You will feel as if, whoa, macam tu, macam kau mau terangkat ke atas. Okay, and it's a very normal feeling. Okay, which is why, let's say the lift, you know how lift is like, right? So lift actually the other cable lah. Okay, and the cable is very strong. Okay, so what if the cable putus? It's everybody's nightmare lah. Okay, what if the cable on the lift putus? The cable on the lift putus means what, you know? Okay, sorry. If the cable on the lift putus, means your lift is going to go down with an acceleration that is the same as the acceleration of gravity. Okay, think about this. If the acceleration is the same as the acceleration of gravity, you're going to get mg minus mg, which is going to be 0. Means the reading on your weighing scale is 0, and we call this situation weightless. So if you ever want to know how an astronaut feels when he's in outer space, macam mana dia boleh terapung-apungkan, how does it feel to be weightless? Okay, tiada apungan makan. Go inside a lift and pray very hard that the lift will putus. Then you will definitely feel how it feels like to be weightless. For about 3 seconds before boom, okay, the lift crashes to the ground, and then you'll be like forever weightless. Okay, so theoretically, it's true. You know, if the lift putuskan, everybody is going to be floating inside the lift. Nobody is going to be able to stand. Everybody's just going to float around in the lift. They're probably going to scream before before they crash. Okay, so anyway, so yeah. So let me summarize this. Let me summarize this in a easier way to understand, which actually you have in your this one. So in short, dalam situation lift, if there is no Allah, now I have to turn on the pen. So annoying. Okay, if there is no acceleration, okay, if there is no acceleration, W equals to R. Okay, but there are two situations where there's no acceleration. Those of you who still don't understand what it means by no acceleration, go and ask Wilson. Wilson is good at this already. Okay, Wilson sudah mula glow up ini. Wow! Okay, but if there is an acceleration, there are two situations. Acceleration upward and acceleration downward. Kalau the lift is accelerating upward, okay, the R is going to be less than the mg. Okay, the girl... sorry. R is more than mg. My mistake. R is more than mg. Girl feels heavier. Okay, if it is accelerating downward, the R is going to be less than mg. Okay, and the girl is going to feel lighter. Okay, in a totally unrelated to your syllabus punya situation, if their acceleration is the same as gravity, okay, your R is going to be the same as mg, and the girl will feel, girl will feel weightless. Okay, so if you ever want to feel weightless, or if you ever feel that you have put on so many kgs since the start of the MCO, this is a good idea for you to feel weightless. Okay, go into the lift and then potong the cable. Apa saya ajar ini? Okay, so next situation. I don't know whether it is an example. Oh, okay, it's an example. Let's take a look at this now. So a boy of mass 50 kg is inside the lift. Okay, let's sketch the free body diagram using W and R. Eva, tell me the direction of W and R, please. Eva, where's W? Which direction should it be?
Downwards.
Okay, W should be downwards. And where should the R be?
Upwards.
Okay, very good. All right. R is normal, R is reaction force. Okay, so don't forget that. Okay, so calculate. Oh, I'm sure they've drawn it there. Oh no, saya sudah kasih tunjuk. Okay, calculate the magnitude of the normal reaction R when the lift is stationary. Okay, when lift is stationary, R equals to mg. Okay. Yeah, okay, when the lift is stationary, R equals to mg. Okay, so 50 times, my mistake, okay, this should not be 10, this should be 9.81. Okay, so yeah, so sorry, some of this slide is still old syllabus. So old syllabus, we learned that G is 10, but you guys are more updated, so you are supposed to learn G is 9.81. So ini silap, okay? Okay, 2, moving upward with an acceleration of 2. Okay, upward with acceleration of 2 means we are talking about what? R minus W or W minus R? Somebody just answer. Which situation are we talking about? R minus W or W minus R? Kalau acceleration ke atas.
R minus W.
R minus W, okay. R minus W, tapi W juga sama dengan mg lah. So I'm going to write R minus mg equals to A. Okay, and therefore, I have all I need. I just want to find what is R. Okay, so R equals R minus M is 50 times 9.81 equals to 50 times the acceleration is 2. Okay, the key to understanding this problem is to remember that the resultant force must be the same direction as the acceleration. So itu yang akan membantu kamu untuk mengira yang ini. Okay, therefore we will get the answer 600 newtons. This is again silap ini bukan 500 ini sepatutnya benda lain. Okay, so R will be equals to 50 times 9.81 plus 50 times 2. Okay, sorry, I don't have my calculator here, so you guys can count that yourself. Situation number 3, move downwards with the acceleration of 1.5. Isabella, tell me how I should write my R and mg. Or R, dari segi R dan W lah. Kalau dia moving downwards with acceleration, how would I write my R and W?
W minus R.
Very good. Okay, W minus R equals to MA. Okay, and I can substitute W as mg. So you get mg minus R equals to MA, and then calculate R. Okay, so you get apa ini? 50 times 9.81 minus R equals to 50 times the acceleration is 1.5. Okay, can somebody tell me the R for number 2 and the R for number 3, please? You know what? I shouldn't just say somebody, right? Okay, Jacinta, can you do number 2? And Miss Tian, number 3. Tell me the value of R for number 2 and number 3. Since the answer in this slide is memang salah, bukan 600. Can you calculate that for me, please? Jacinta, number 2, and Tian, number 3.
Answer for number 2 is 590.5.
Okay, 590.5 what? Ringgit? Lama sudah saya tidak cakap ini.
Newton.
Very good. Okay, reaction force, all forces are Newton. Miss Tian, number 3.
415.5. 415.5.
415.5. Okay, 415.5.
Newton.
Okay. Newton. Okay, very good. So this mathematically proves our point. When an object is moving upward, okay, the girl is going to feel heavier. The reading on the weighing machine is going to be heavier. Although she's actually only 50 kilograms, 500 newtons, about 500 newtons. Okay, but she's going to feel heavier. But when it is moving downwards with acceleration, she's going to feel much, much lighter. Okay, but her weight actually doesn't change. It is changing because of the acceleration. Okay, that's why again, as I mentioned in the previous class, very important for us to differentiate between weight and mass. Okay, because we are not just anybody, you know, we are physicists. Okay, so we are very elitist one. Okay, kita sangat elite ini. We have to differentiate between mass and weight. Okay, so obviously this answer is wrong, so I'm not going to bother. Okay, the third situation, and this is by far the most difficult situation. Okay, so I'm going to say sorry very early. Okay, this is a very difficult thing to cover on a Wednesday afternoon. Okay, something has happened. Sorry, are you still seeing the slide? Something happened on my computer, so I'm kind of wondering. You can still see the slide, Okay, so in this situation, you have an object that is pulled by a pulley. Okay, so ini adalah satu pulley. Dalam bahasa Melayu, ini dipanggil sebagai takal. Okay, usually where do you see this? Can anybody tell me where you see pulley before? Nobody can think about where you see pulley before. Are you sure you have ever been to school for the past 10 years? Even though last year you only went to school for that. Correct. Okay, the bendera. Whenever you lift the flag, you think the flag go up by what? Okay, there is actually a pulley up there. Okay, so there are two forces. One is the force of the bendera. Okay, so let's say this is the bendera lah. Okay, and then this one is the guy that is pulling out the bendera. Okay, negaraku, then pull up. Okay, another one that is very famous is if you ever been to a fish market. Okay, sometimes people will get the fish that is higher than me, is taller than me, taller than maybe Oswald or even Lester. Okay, how you think they're going to carry the fish? Okay, they want to see how long is the fish. You think everybody got measuring tape and then bring to the... No, what they do is they will pull the fish up. Okay, they will gantung the fish over here. Sorry for my sad excuse for fish, but this is a fish. They will gantung the fish here and then they will pull it up so that people can actually see how long it is, you know. Okay, and then I'm sure, I don't know whether you've seen this before, but you know, got people take photo with the fish one, you know, because it's so amazing. Wow, I never seen a fish that is taller than me, you know. Okay, it's like a sightseeing program like that. People will be like, wow. So that's why we use pulley for all these kind of purposes lah. Okay, tapi bukan saja untuk bendera and to angkat fish lah. No? There's a lot of uses for pulley as well. But here we want to talk about the situation where we have an object. Okay, you have two different objects. This first situation is two different objects. Okay, I'm just going to go through this once go lah. So obviously, everything that has mass will definitely have weight. Okay, so you have this actually shouldn't be 40 newtons. This should be 4 times 9.81, which is how much? 4 times 9.81, somebody please? Saya menyesal saya punya calculator jauh begitu. 4 times 9.81?
39.24.
Okay, thank you. 39.2. I'm just going to use. So this is 39.2 downwards. Okay, and then the next one, 3, this one also, please, in terms of 9.81. How much is this weight actually? 29.4. Okay, I'm just 39. 29. Okay, thank you. Okay, 29.4. Okay, Newton, since we're using 9.81. So you have these two things of different mass lah. Okay, so so if you're talking about a string, okay, if you're talking about pulley, there's this upward force which is not a reaction force. The upward force is called the tension. Okay, and since this is going downwards here and since this is going downwards here, there's going to be tension on both the strings. Dua-dua akan mengalami tension. Okay, and the tension is the same value. No matter what happens, the tension will be the same value. Okay, because they are being pulled by the resultant force. Okay. Okay. Hi everyone. So firstly, I want to apologize because just now during our class, in this pulley question, I made a mistake. Okay, I overlooked certain things. So this is the correction video lah. Okay, so yeah, so let's take a look at this lah. Okay, so first of all, we have the same situation as we saw just now lah. Okay, so 4 kilograms and then 3 kilograms, but our weight is a little bit different now. Since we're using 9.81, the 4 kilograms will be 39.24 newtons. Okay, and then the 3 kilograms will be 29.43 newtons. Okay, now in discussing the pulley, okay, actually the free body diagram cannot be separated because they are one flow like that lah. Okay, so if you think about it, okay, if you have a 4 kg on one side and a 3 kg on the other side, okay, everything is going to go towards the 4 kg lah. That's very logical because the 4 kg is heavier. So the resultant force, okay, the step to answering this is to first calculate the resultant force in terms of the two forces there are. So the resultant force will be 39.24 minus 29.43. Okay, since the 39.24 is bigger lah. Okay, so you will get 9.81 newtons. Okay, then after that, the moving mass, okay, the moving mass is 4 plus 3 because the entire thing moves in itself. So we treat both masses as 1. So ini akan jadi 7 kg. So we can use the F equals to ma to find the acceleration, which is 9.81 equals to 7 times a. And you'll get a equals to about 1.40 meters per second squared. Okay, so we need to find the acceleration first, since the acceleration is the same for both. Then after that, we use the formula that we know just now. Okay, we separate it to find the tension. Okay, so over here, you will have, in the free body diagram, let's say the 4 kg one. Okay, even if you use 3 kg, so doesn't matter. Okay, but we know that since the 4 kg, the acceleration is downwards. Therefore, okay, so what you will get Since it is 39.24, so it will be it will be 39.24 minus T equals to, the mass is 4, okay, times 1.40. Since we are only looking at the left side, okay, so the mass will be 4. We only consider the mass now. Okay, and then after that, you will finally get T equals to, you'll get about 33.64 newtons. Okay, and if you do the same thing with the right hand side now, okay, kalau sebelah kanan ini, this will be T minus 29.43 equals to 3 times 1.40. Okay, so you'll get 3 times 1.4 plus 29.43, you will get about the same 33.63 newtons. Okay, so this is how to answer a question that involves the pulley lah. You have to combine the mass to find the acceleration. Then after that, you separate it to calculate the tension. Actually, you do, kalau kamu buat 11 saja, you just do one. Okay, you don't have to do the other one lah, because actually the tension and the acceleration is the same. Okay, so if you don't get this, watch it again, okay, and take it slow. The step is a little bit different lah. Okay, we have to first calculate the acceleration and then use the acceleration in either one of the situations to calculate the tension. Okay, so that's the first one. The second situation is this. So instead of two things now on one pulley, you still have the same pulley over here, okay, except that now you have a trolley, okay, and you have a trolley on a surface. Okay, so this is slightly different, but still the same concept. Okay, still the same concept. Trolley with a mass of 2 kg. Okay, being pulled on a table with a load through a pulley. The trolley moves with an acceleration of 5 meters per second squared against a friction of 4 newtons. So the friction is ke belakang lah, 4 newtons. Okay. Now, what is the name of the the force that is pulling this trolley? It is the tension of the string. Okay, and tension of the string is T, and we know that in the case of this pemberat over here, the tension is also upwards. Okay, so sorry, I'm doing the sketching of the free body diagram now. W is the weight of the trolley. Here is W. R is the normal reaction force on the trolley. R is upwards. Okay, G is friction. G is 4 newtons. T is the tension of the string. Okay, yang sememangnya dia akan suruh kamu kira. Okay, and B is the weight of the load. So over here is B, which I also know is actually mg lah. Okay, the mass times the gravity. Okay, can somebody wait ah? Okay, can somebody count for me the value of B, please? Anybody just count and then let me know the value of B. What is the value of my weight? 2 kg equals to how many newtons?
19.62.
Okay, very good. 19.62 newtons. Okay, so let's talk about this. First of all, compare the weight of the trolley, this one, okay, and the normal reaction force, W and R. For any object yang sedang bergerak di atas satu permukaan, what can you tell me about the weight of the trolley and the normal reaction force? Daniel, do you remember how to compare? It's either bigger than, smaller than, or same.
R is bigger than W.
R is bigger than W. What do the rest of you think? Think about it now. If R is bigger than W, where is this trolley going to go? Oh, it's going to go upwards, you know. But this trolley is not going upwards. It's going left and right only. Okay, so by right now, can you correct this, please, Daniel? If the trolley is only going left and right, what about the R and the W? It should be
W is bigger.
W is bigger than R. Think about it, huh? If W is bigger than R, where is this trolley going to go? It's going to go downward, which is what we don't want. Okay? Since this trolley is neither going up nor down, actually it should be W equals to R because it's not going up or down. This is a very important point. Okay? If something is going left and right, it's not going up or down. Okay? Then that means the reaction force and the weight is the same value. The moment you have an imbalance of forces, it's going to go in the direction of the bigger force. Okay, so be very careful with this. Okay, calculate the resultant force acting on the trolley F. Can we calculate the resultant force? Yeah, we can. Which method do we want to use? Who else haven't I called? Eliska. I haven't heard from Eliska today. Can I, Eliska?
Cannot.
Okay. Now remember, ada dua cara untuk mengira resultant force. Okay, satu cara adalah one force minus another force. The second cara is menggunakan mass times acceleration. So actually you can have the resultant force equals to 2 times 5, which is 10 newtons. Okay, so kita mesti, we have to learn to be macam flexible sikit lah. Okay, remember that there are two ways. Bergantung kepada what information is given. Okay, calculate the tension in the string pulling the trolley. Okay, now kalau kita mau calculate tension, we have to consider the second method of counting the resultant force. Okay, dari segi T dan G. Okay, Mordecai. Have I called Mordecai yet? I haven't called Mordecai, right? Okay, Mordecai. Dari segi T dan G, tell me the resultant force.
The resultant force plus with weight.
No, not yet. T dan G sahaja. Tell me the resultant force in terms of T and G only. Kan ga? Follow the direction of the acceleration. It is accelerating to the right. So that means kita punya resultant force
To the right.
is so is what are the two forces? T and G bahkan.
T equals G. T equals mg.
No, cannot be. E cannot be equal to mg. Think about it. Force ke depan is T, force ke belakang is G. Since it is accelerating to the right, so the resultant force will be T minus G. Right? Sama dengan the second cara kita kira resultant force, which is 10. Okay. And since I have the value of G equals to 4, so I can get the value of T. What's the value of T? Same person, Mordecai?
14.
Okay, T equals to 40 newtons. And that's a very important information for us. Okay, because we can use the same T in this situation. Okay, let me draw the pemberat. Pemberat, we have this T upwards, we have this B downwards, which is 19.62, and it is going to accelerate downwards. Okay, same thing. Sorry, apa ini? What is the value of T? 14. Okay, can we find the mass of the load? Can. We still use the same method, F equals to MA. Okay. Can you tell me the resultant force? Anybody? In this situation? Dalam case pemberat ini.
W tolak MA.
Cannot be MA. What is the force upwards? The force upwards is the tension. So it's actually 19.62 tolak the tension, which we calculated just now, which is 14. Now I'm kind of wondering whether you can see this. Maybe my writing is too small lah kan. Oh dear. Okay, tak apa. Sama dengan M. What is the acceleration? We use the same acceleration as before, 5. Okay, since the tension is the same, the acceleration also will be the same. So kita boleh kira M dari sini. Okay, Chrislia, can you calculate the M for me, please?
1.16.
Saya kan kira salah. Minus 14 divided by 5. 1.124. Okay, yeah, maybe my writing is
Itu
tiny lah.
19 ke 14?
Sorry, 19. 19. Yang di bawah sini 19.62. Yang di atas ni 14. Yeah. Okay, it's okay. No worry, ya. Betul. Fine. A student studies the effect of movement. Dia punya mass adalah 50 kg. Okay. Yada. So look at the reading lah. Okay. So the mass of the student 50 kg. What is the weight of the student in newtons? How do I calculate the weight? Can somebody suggest to me, please? Macam mana saya mau kira weight kalau saya diberi mass?
Times 9.81.
Times 9.81, okay. Wow, I can hear my own voice. Okay, times 9.81, which will give you, somebody?
490.5.
Okay, 490.5 newtons. So, state two types of movement when the reading of the weighing scale is equal to the mass of the student. The student is 50 kilograms, by the way. So which is the movement where the reading of the weighing scale is the same as the mass? Anybody? Just give me the answer straight away. Ini tidak payah jadual pun kamu tahu ini. When is R equals to mg? Kalau dalam
Uniform velocity.
Okay, uniform velocity and one more?
Stationary.
Okay, stationary. Very good. Okay, F is the resultant force that acts on the student. R is the normal reaction of the weighing scale on the student. G is the banyaknya ini. Okay, write a general equation to show the relationship between F, R, M, and G. Dia tidak bagi pula kan this equation. It's okay. You know what? Okay, F equals to R minus mg. Okay, sebab kalau dia ke bawah mg, ke atas is R makan. So let's assume lah that we are going upwards. Okay, we have an acceleration. So our F equals to R minus mg. But F is also equals to ma. Okay. Never mind, don't worry about this. Okay, kita anu saja. When the lift moves up with acceleration, the normal reaction is greater than his weight. Why? Kalau dia bergerak ke atas, dia rasa lebih berat. Kenapa? Why? Explain why pula. Dia minta explain why. Ouch. Why? Because the upward resultant force is mg plus ma. Okay, begitulah. That's how we would answer this. So what is observed on the reading of the weighing scale when the lift moves down? When the lift moves down, what happens to the reading of the weighing scale? It will, oh, come on. Okay, it will decrease. Okay, and the reason is same thing. Where is the direction of the resultant force? It's going downward. Sorry. Oh, come on. Okay, downward resultant force, downward resultant force. Therefore, R equals to mg minus ma. Okay, that's it.